Okay, so let's have a look at this another circuit example. Here we see the PNP transistor is connected as shown. It is a PNP transistor which has a three terminals such as collector, base and the emitter, and we see that the direction of the current is going inside the emitter, so that indicates it is a PNP transistor. In PNP transistor we know that the majority of charge carriers, the current due to the current that flows is due to the majority of charge carriers which are holes. So we see that the current flows from emitter to the collector in the PNP transistor. Now let's indicate the notations. P is emitter, N is base and P again is collector. Now Vi is an external voltage and AC alternating current signal that can be applied across these two terminals, and VO is an output voltage that is again the alternating current signal that will be taken across these two terminals. And these two voltage sources VEE and VCC are used to provide the biasing to this BJT circuit through the resistors as shown. So when I say the DC biasing, it means it sets the operating point of this circuit or Q point of this circuit around which this AC signal that is applied externally will be processed. For example, it will be amplified by this circuit. So now let us see the biasing condition. So this voltage source, the positive of it is connected to the emitter through the resistor RE. The negative of this voltage source goes to base. So with this we see that the positive is connected to the P and the negative of the voltage source is connected to the N. So this makes the emitter base junction forward bias, and we see that across this junction, across the junction the forward biasing is applied. So the voltage across this emitter bias junction would be called as VBE. VEB actually, that will be applied across this junction. Now let us have a look at this voltage source. The negative of this voltage source is connected to the P again. This is PNP, remember. So the P type of material is here, which is a collector, is fed with the negative battery terminal, and the positive of this voltage source VCC goes to N. So this makes this base collector junction or collector base junction reverse bias. So we can say that the voltage that will be applied across this junction will be VCB. Okay, so you have two terminal which is VEB and you have VCB. Okay, so when you have this junction forward bias and this junction reverse bias, the transistor is biased in an active region, and that's how the circuit will function. So that is how the circuit will work.